Here are video answers to the worksheet about implicit differentiation applications involving trig, as you see right here. So for this question, it asks us to determine what y prime is. So should be easy enough. The derivative of tangent is secant squared. Leave the inside alone, so of y. Then times the derivative of the inside, which is the derivative of y prime, minus 4 times the derivative of y, which is y prime, plus the derivative of x, which is 1, equals the derivative of 2, 0. Collect all the y prime terms on one side. All the terms without a y prime go to the other. Factor out a y prime. And divide. And we have y prime. So this is going to be useful to a lot of the problems coming up. So here we go. I'll just get rid of that. It's not working. So the equation of the tangent line is y minus f of c equals f prime of c times x minus c. Now, that's for a function of x. This is a function of both x and y. So really, is that really valid here? But we can make it work. See this f prime of c? The derivative is based off x and y. So really the only adjustment we need to make is x comma y being this. So let's fill everything in. Y minus f of 2, which is 0, is always y minus y1, equals f prime at 2 comma 0 times x minus x1 or x minus c, which is 2. So let's remember our derivative was y prime equals negative 1 over secant squared y minus 4. So when we plug 2 comma 0 into that, you'll get y prime equals negative 1 over secant squared of 0 minus 4. Secant of 0 is the reciprocal of cosine of 0. And cosine of 0 is 1. Remember, because cosine is x. And that's 0. So we have negative 1 over 1 squared minus 4, or negative 1 over negative 3, or 1/3. So we have y equals 1/3 times x minus 2. If you want it, well, let's keep it like that. So I'm going to refer to the graph of this function just to kind of check. And you should actually do this. I lost it. I thought I had it. So you should actually do this. Play around with Desmos, especially when you're doing these implicit differentiation problems. I just did it, so here we go. That's the equation. Here's the graph. It's a really, really strange looking graph. Look at it. So, but this question was, what's the equation of the tangent line here? Well, it looks like the tangent line is going to look, it's going to be positive slope, not a big positive slope like we had 1/3, and the y-intercept is going to be somewhere down here. So our answer looks promising, but let's not settle on promising. Let's just plug it in. 1/3 times x minus 2 and see if it's the equation of the tangent line. So 1/3 times the quantity x minus 2. And when it graphs that tangent line, you're going to see it's perfect. So I'm very happy with that answer. Let's go to the next question. Are there any points on the graph that have a horizontal tangent line? Justify your answer. So horizontal tangent line is where the derivative equals 0, where the slope is 0. So we're going to set this derivative equal to 0 and solve. And remember, a fraction equals 0 when the top equals 0. So we can just write this equation. And this is obviously a false equation, which indicates no, there are no solutions to it. So there are no points that this graph has a horizontal tangent line. And again, if you look at the graph, it's hard to see because it looks like it's flattening out. But if you look at it, all these lines are slowly decreasing. They never even out. They're always going down. And even when you look up, you can see from here to here, that graph is going down. So it never gets completely flat. Therefore, there's no horizontal tangent line. Last question. On the interval between 0 and 2 pi, that's from y, there are 4 points on the graph that have vertical tangent lines. Find the y coordinates. So referring back to the graph, we're talking about the interval between 0 and 2 pi, which is about 0 and 6. Here and about here, because it's saying y. Are there any spots that there are vertical tangent lines? Well, that would be where the tangent line goes up and down. So I'm thinking, here's one. See that where it says pi over 3 for y? Here's one. See where that says 2 pi over 3 for y? Here's one. 4 pi over 3 for y. And here's one. 5 pi over 3 for y. So those are the 1, 2, 3, 4 points that we're looking for. Now we're going to get them. So a vertical tangent line is where the derivative is undefined. Since the derivative is a fraction, and a fraction is undefined where the bottom equals 0, you can't divide by 0, we're just going to solve this equation. This will tell us where the derivative is undefined and therefore where those vertical tangent lines are. Solve it by adding 4, square rooting both sides. Don't forget you get plus or minus when you square root both sides, and the square root of 4 is 2. I don't like secant, so I'm going to change it to cosine. It's reciprocal, which means I'll have to reciprocate the 2. So now we have to figure out, and remember, we're solving for y, which is good because we're saying y is between 0 and 2 pi. So we're on one revolution, one positive revolution of the unit circle. Cosine is x. So cosine is 1/2 on the short distance right here. Also negative 1/2, so right here, as opposed to over here for the root 3 over 2, or over here for negative root 3 over 2. So that would correspond to this both, this one, and also this both for this one. And this one corresponds to this both and this both. So now all we have to do is count the spokes. They're the 4 spokes we didn't use. So this one is 2 pi over 6, 4 pi over 6, 3, 4, 5, 6, 7, 8 pi over 6, 9, 10 pi over 6. So if you remember what we saw on the graph, those were the y-coordinates of all those points that had vertical tangent lines. So that should do it. Now, if it didn't say just y-coordinates, if it said points, you would need to throw these back into the original function 4 times, each one separately. So if we're doing the 5 pi over 3 one, to get the x-coordinate, we would have to and solve for x. Now that's going to be a pain because this is a whole bunch of irrational stuff, but you definitely can see hopefully that you can solve for x. So the last thing I'm going to do is, well, it might be a good idea to try this on your calculator, just solve for x, and then see if you get it, because I'm going to show you the answer through Desmos in a second. If you want to pause, but here I go. Back to Desmos. The pi over 3 point right here, the x value, you should have gotten 4.457. So that's it. Hopefully that helps. That's a pretty challenging one. So if you're good with that, excellent.